Okay, so here are our solutions for the first section. So the first two are just writing the augmented matrix for these systems of linear equations. So the augmented matrix is the first step, and what you do is you take the coefficients in front of the x and y and the constant that's on the right hand side and put those into a matrix. So we have 4, so the first column is the x coefficients, and the second column is the y coefficients, and the third column is the numbers on the right hand side. So that's this equation. Then you have the next equation, which is -1, 3, and 12. We draw it as a matrix, these brackets, and you can write these little dots kind of to show it's an augmented matrix. Okay, so that was it. Number 2, we've got 3 equations and 3 unknowns, so the matrix is going to be bigger. The first column, what we said here up here was the first column was x, the second column was y, and we can call this third column c for constants. So in this case we're going to have x, y, z, and c. So the first equation, we have -1x plus 8y plus 3z equals 8. The second one, you'll notice there is no y term, so when you don't have a term you put in 0. And then the third equation, we do have all 3 of them, so we have 2x plus 3y minus 1z equals 12. And then you put your right bracket, little dots here. The dots kind of are a way of showing that it is an augmented matrix. Okay, it's just a shorthand way of representing the same information. We just don't have the x, y's, and z's written in there. But they have to be in a particular column. We wouldn't put 0, -5, 7 or something like that. We'd have to make sure that -5 goes with the x, so it's in the appropriate column. Okay, the next thing you can do is take a matrix and go the opposite direction. So these just to show that they are equivalent to each other. So here we have the augmented matrix. We have x, y, and c. So for number 3 you have 7x minus 5y equals 0, and 3x plus 8y equals -4. So those are the 2 linear equations, and we could go back to the old way of using substitution or elimination to solve for x and y, but what we're doing is using the matrix version. And here we have 4, so you'd have x, y, z, and w, and some constant c. So we got 9x, 12y, 3z, and 0w. We don't need to put it in there, but we will leave a space, and that equals 0, the right hand side. Okay, the next row, -2x plus 18y plus 5z plus w equals 7. Okay, so -2x, 18y, 5z, 1w, 7. Okay, the next one we have 1x, so I'm just going to put x, plus 7y minus 4z plus 2w equals 5. And then here we have a 0, so we leave that blank. You don't need to, when it's the first term, you don't need to put a plus sign. So it's 9y minus 2z minus w equals -7. Okay, so we go from equations to matrices, augmented matrix to equations. Now the next thing to do is to look at these row operations. So there are 3 row operations. There are just switching rows. That's usually done if one of the rows has a 1 in the place that we want it to be, but in the wrong. You know, if this 1 were here instead of there, I just switched the 2 rows, and so that's one row operation. And then the second row operation is to multiply or divide a row by a constant. And the third operation is to multiply one row by a constant and add or subtract it from another row. So that's we're going to practice that. Now ultimately, to solve equations, you do that multiple times until you get the desired result, which we'll talk about that in a second. So here's the first case. So you see the first rows are the same. The difference is the second row is 0. So of the 3 operations, we're not switching this because there's nothing to switch it with, because we just left row 1 the same. We couldn't multiply by 0 because then we just end up with 0 times 0 times 0, 0, 0, which is pretty useless. So it must be the third method. So what I'm going to do is I'm just going to take this and just move it down a little bit. So typically, if you want to get a 0 here and you have a 1 in the other row, you multiply this row by a constant and either add or subtract it from the original row. So we usually show it by writing out what we're going to do here. So what we're going to do is we're going to take row 2, the original row, and we're going to subtract 2 times row 1. And what that'll do is it'll make this a 0, and hopefully it'll make this a -1. So let's take row, since we want to subtract 2 times row 1, let's take 2 times row 1 here. 2 times row 1. So that means I take row 1 in the previous step, multiply it by 2. So 2 times 1 is 2, 4 times 2 is 8. So 1 times 2 is 2, 2 times 4 is 8, 2 times 3 is 6. So that's 2 times row 1. Then if I take row 2 here and I subtract 2 times row 1 from it, 2 minus 2 is 0. 10 minus 8 is 2. 5 minus 6 is -1. So that last one, I didn't need to show this. It just confirms that I'm doing it right. I could have left this blank. Just to get a 0 here, I have to do this. So again, R2 minus R2 times R1. This minus that equals that. This minus that equals that. This minus that equals that. Okay, so that's it. That's all that was involved in that problem. Just doing start of simple. Okay, the next one is a little more complicated. You can see the first row is the same. And what I'm going to do, I think, is I'm going to move this over to the next page. And I'm going to move this down. And look what we need to do. So if you look at this, we've got the first row is the same. And again, it has a 1 here, which is always important. If this were not a 1, then we would do something to make it a 1 by dividing everything by whatever, and we'll get to that later. Okay. So the first thing you see is they have a 0 here. Row 2 initially, this is R2. Row 2 initially here. Row 2 is 3, but we want it to become a 0, and we need to use row 1 to do that. So what we would do is we would take row 2, the old row 2, and we're going to subtract. So to get from 3 to 0, I've got to subtract 3 times row 1. So subtract 3 times row 1, just like I subtracted 2 times row 1 before. The reason I subtracted 2 times row 1 here was because this was a 2, and this is a 3. Okay, so I'm going to do the same thing. I'm going to take 3 times row 1, put it right above here. So 1 times 3 is 3, 1 times 3 is 3, 4 times 3 is 12, negative 1 times 3 is negative 3. So this row is just a multiple of that row. And what basically, you know, if you take any equation and you have a common factor, you can always simplify it by dividing by that common factor. But you could also multiply by a common number, and you'd still have the equality would still apply. So by multiplying this by 3, I'm not changing anything. So when you solve polynomials, and if you have a common factor, you can always factor that thing out. Okay, so what I'm going to do now is I'm going to replace row 2, the old row 2, by taking old row 2 and subtracting 3 times row 1. So I'm going to take this minus that. So 3 minus 3 is 0. 8 minus 3 is 5. So that just confirms that I'm doing it right. 8 minus 3 is 5. 10 minus 12 is negative 2. And 3 minus a negative 3 is positive 6. So this is 8 minus 3 is 5. 10 minus 12 is negative 2. 6 minus a negative 3. That's the same as 6 plus 3. It's plus 6. And then you do the same thing for the third row. So here's row 3. What I want to do is to get a 0 here. So I'll do the same thing. I'll take the older row 3, and because this is negative 2, I'll subtract 2 times row 1. Actually, I want to subtract a negative 2 times R1. Okay, or you can think of that as row 3 plus 2 times R row 1. So let's do that up here. So 2 row 1. Here's row 1 again. So we multiply each one of these by 2. 2 times 1 times 2 is 2. 1 times 2 is 2. 4 times 2 is 8. Negative 1 times 2 is negative 2. Okay. And I was subtracting a negative 2 times R2, or just adding 2 times R. Say, subtracting a negative 2 times R1, which is the same as adding 2 times R1. So I'm just going to take row 3 and add this. So negative 2 plus 2 is 0. 1 plus 2 is 3. So that confirms I did it right. 2 plus 8 is 20. And 6 plus a negative 2 is 4. So that's that one. Okay, I'm just making sure I did everything right here. So let's just double check here. So I took 2 times row 1. This is double, double, double. Then I added these together. So these added together give me 0. This plus that equals that. This plus that equals 20. 6 plus negative 2 is 4. Okay. So that's the answer for the first part. Now, if you come over here, what you see is I've got the first row is the same. The second row looks like, to get 1 here, I just divide everything by 5. So that's what happens. So you can see how I've divided everything by 5. And so the same thing applies down here. If I want to get a 1 in this location, I do the same thing. Here I divided by 5. Here I'm divided by 3. So 3 divided by 3 is 1. 20 divided by 3 is 20/3. And 4 divided by 3 is 4/3. So that's the final answer. Now here they're asking you what to do. We're telling you what to do. Again, it's what we're trying to do is, if we have a matrix, we either want to get something like this. If it's an augmented matrix this size, if it's this size, you want 1 0 1 0 0 1. You don't necessarily need to have zeros in here. So that is that's kind of the process, and that's what these series of operations are going to do. They're going to result or push us in the direction of getting those correctly done. So what I'm going to this is not an augmented matrix because it's three rows by 3 columns, but it's just a practice of doing these specific row operations. We're going to do the first 2 row operations first, and then we'll do the next ones after that. Okay, so that's the same thing. I'm just putting it over here. So what they want us to do is they want us to just leave row 1 untouched. And that's good because it has a 1 in the first place, right here. Then they want us to do add 3 times negative 3 times R1 to R3, or R3 minus 3 times R1 is the same thing. And actually that's B, that needs to go down here. That's row 3. And then you have this one here, which is row 2 minus 2 times R1. That's what they're saying. 2 minus negative, it's either R2 plus negative 2 times R1, or negative 2 times R1 plus R2, or R2 minus 2 times R1. This is the one I'm going to use. And then what I'll do is I'll do 2R1 here, and I'll do 3R1 here, and then we'll do each one of those separately. So this is 3 times R1. So all we do is we take row 1 and multiply by 2, so we get 2, 4, 6. Each of these multiplied by 2. And if you multiply by 3, you get 3, 6, 9. Then what we're going to do is we're going to take row 2, this is the old row 2, and we're going to have a new row 2. And new row 2 is going to be old row 2 minus 2 times R1. So we're going to take this, subtract that. 2 minus 2 is 0. Negative 1 minus 4 is negative 5. And negative 4 minus 6 is negative 10. Now, up here, we're going to take the old R3, or row 3, and we're going to subtract 3 times R1. So we're going to take this number and subtract that number. 3 minus 3 is 0. 1 minus 6 is negative 5. Negative 1 minus 9 is negative 10. So we end up with that. So that's the first thing we did. We did both of these. Now, the next step says add negative 1 times R2 to R3. So that now I'm into this new matrix. This is now the new R1, and this is the new R2. I've substituted. This is the new R3. So what they want me to do is multiply, add negative 1 times R2 to R3. So that's the same as R. I'm going to move this down a little bit here. What they're saying is take R3 and subtract 1 times R2. So I already have R2 here, so that's easy. So what I'm going to do is I'm going to take this row and I'm going to subtract this row. So I'll get 0 minus 0, which is 0. And then I will take negative 5 and subtract a negative 5. Well, negative 5 minus a negative 5 is 0. and likewise negative 10 minus a negative 10 is 0. So I get 0, 0 for that particular operation. The other rows didn't change at all. Okay, so that's that one. Now the next step says, now again, these, now with that we've rewritten it. This is R1, this is R2, this is R3. So what we're going to do is multiply R2 by negative 1/5. So that means that these are the first and the last are the same. We're going to make R2 and we're going to multiply by negative 1/5. Well, 0 times negative 1/5 is 0. Negative 5 times negative 1/5 is 1. And negative 10 times negative 1/5 is positive 2. So that's that. And finally it says add negative 2 times R2 to R1. Another way of writing that is R1 minus 2 times R2. And I really need to add another up here, because what I have now is, you know, this is R1 now updated, R2 updated, R3 updated. So what I'm doing now is my last operation. So I'm going to take R1 and subtract 2 times R2. So you can see this is the one I'm replacing. Row 1 I'm replacing with row 1 minus 2R2. So I'm not changing row 2, not changing row 3. What I'm going to do is take, so let's write this up here. If I take 2 times R2, so I take row 2 and I multiply by 2, so I get 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and then I'm going to take row 1, I'm going to subtract 2 times row 2. So 1 minus 0 is 1, 2 minus 2 is 0, 3 minus 4 is negative 1, and I'm done. So what you find out is what happened here is I got 1s mostly on the diagonal, and I got a lot of 0s, and that's the whole idea, is to try to get as many 0s and 1s as possible in a specific locations. Okay, so now this is where the rubber hits the road, and what we're going to do is we're going to use matrices to solve these systems of equations if possible. And you can either use Gaussian elimination with back substitution or Gauss-Jordan elimination. I'll show you both ways to do it. So we've got problem number 8. First thing you do, write it in matrix form. 1, 2, 7, 2, 1, 8. Put little dots here. Okay, so that's the augmented matrix version. What I'm trying to get to is this. First, I'm going to try to get to, well, I want to get 1s on the diagonal and 0 here. We don't want it, we can get numbers there, whatever they end up being, but that's the goal. That's to do Gaussian elimination with back substitution. To do Gauss-Jordan elimination, we'd have a 0 here as well. That requires one more step. So the first thing you want to do in these is you want to have a 1 in the upper left hand corner. Well, we already do, so that's great. We don't have to save this time. The second thing we do is we want to get a 0 here. So how do we get a 0 here? How do we use row 1 to get 0 here? Well, what you can do is take row 2, this old row 2, and subtract 2 times row 1. Because if I double this, I'll have 2, and then I'll have 2 minus 2 is 0. So let's write 2R1 right here, which is what I'm trying to do. So take row 1, multiply by 2, multiply by 2, multiply by 2. So that's 2R1. This is R2. This is row 2, so 2 minus 2 is 0, so that was right. 1 minus 4 is negative 3, and 8 minus 14 is negative 6. So I've got 1, 0. Now I need for this to be a 1. Well, all I have to do here is divide row 3. So I'm going to take row 3, divide by negative 3. So 0 divided by negative 3 is 0. Negative 3 divided by negative 3 is 1. And negative 6 divided by negative 3 is 2. So what I've got now is where I wanted to go. I wanted 1, 0, 1. So how do you use that? So, you know, this was the augmented matrix of the original equation. This is the augmented matrix of it's the same information, it's just rearranged differently. So I can go back to the equations. The first column is x, second column is y. So I have 1x plus 2y equals 7, and I have 1y equals 2. Well, hey, there's one of my solutions, y equals 2. And then I can use back substitution by saying, okay, well here, now I know y, I can plug that back into here, like that. So instead of 2y, I can have 2 times 2. So that's x plus 4 equals 7, x equals 3. So that's my solution, x equals 3, y equals 2. Okay, and that was the whole idea. And you know, if we look at the original equation, which was x plus 2y equals 7 and 2x plus y equals 8, and we plug these values in, we can confirm that that's the right solution. So 3x is 3 plus 2 times y, which is 2, is 7, which is what we hope for. 3 plus 4 is 7, so that's check. And the second one is 2 times x, which is 3, plus y, which is 2. That should equal 8. Well, 2 times 3 is 6. 6 plus 2 is 8. Check. So we did it right. Okay. So that's back substitution. Okay. Now, what we can do is we can go one more step here and get a 0. And do it on a matrix form. So what we're going to do is we're going to leave the second row the same. And we're going to take row 1 and we're going to subtract 2 times row 2. What that's going to do is it's going to make this go to 0. So let's write 2r2. And this row 1 here is the row 1 that this is row 1 now, and this is row 2, the updated. So I'm just copying row 2 down from here, but we're going to modify row 1. So let's take row 2, multiply by 2. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. So that's 2r2. So now instead of row 1, I'm going to take row 1, subtract this row. 1 minus 0 is 1, 2 minus 2 is 0, 7 minus 4 is 3, and I end up with that. Now, the equivalent of these two, to go backwards to the equations, is you have x plus 0y equals 3 and 0x plus 1y equals 2, or x equals 3, y equals 2, which is what we got using back substitution. And we know that works. Okay. The other thing is you could just go directly from here and say x equals 3, y equals 2. These numbers are your answers. If you have 1, 0, 0, 1, the third column are your answers. Okay, so let's look at the next one. So the first thing we do is we're going to write the system of linear equations in augmented matrix form, like that. Put a little dot there. Now, first thing you want to do is to get a 1 here. And we don't have a 1 here. If this was 1, we just switch rows, but neither one of these are 1s. Then you look to see, can I divide either one of these by a common factor and have avoid fractions? And the answer would be yes. So what we're going to do is we're going to take row 1 and we're going to divide it by 5. So we take each one of these divided by 5, you get 1, minus 1, minus 1. Row 2 stays the same, don't do anything with that, and we end up with that. Okay, which, you know, kind of puts us in this position. Now we have a 1 in the upper left hand corner. So what we want to do here is we want to replace row 2. We take row 2 and we're going to subtract -2 times, that's this number, times R1. Or we're going to take R2 and add R1, or 2 times R1. Okay, so this is now my new R1. This is my same old R2. So to be able to do this, I want to add this plus 2 times that, so I need to get 2 times R1 up here so I can do the math. So I double everything here, I get 2 minus 2 minus 2. And so row 1's unchanged. Row 2 we're going to replace with old row 2 plus the new 2 times row 1. So -2 plus 2 is 0. That's what we're trying to do, get a 0 here. This plus that's that, this plus that is -5. This plus that is 5. Okay, next thing we want to do is we want to get a 1 here. So you can see all we have to do is just divide or multiply. I guess we'll leave R1 the same. Here we want R2 and we want to divide by -5. Okay, so row 1 stays the same. Row 2 is just divided by -5, so this becomes +1, this becomes positive -1, so this becomes +1, this becomes -1. Okay, so using back substitution, what we can say is we can rewrite these as equations, which says x minus y equals -1, and this one says 1y equals -1. So there's one solution, y equals -1. Then I can plug that back in here. So I got x minus a -1, which is x plus 1. Subtract 1 from both sides, you get x equals -2. Okay, so that's my solution to these equations using back substitution. Now to do it using Gauss-Jordan elimination, I take the last thing and I want to make this go to 0. So you can see I can leave row 2 the same, and what I'm going to do is take row 1 and I'm going to add row 2 to it, because I know if I take this plus that I get 0. Okay, so all I have to do is row 1 plus row 2 is 1. Row 1 plus row 2 is 0. Row 1 plus row 2 is -2. Now the corresponding equations here are x plus 0y equals -2 and 0x plus 1y equals -1, but that's the same as x equals -2 and y equals -1, which is exactly what I got over here using back substitution. Okay, so those two problems. Now they're going to get harder. Got 3 long ones. Okay. Yeah, these can wear you out. So instead of having, now we have a bigger matrix. So we have 1, 0, negative 3, negative 2. Okay, 1, 0, negative 3, negative 2. We have 3, 1, negative 2, 5, 3, 1, negative 2, 5, and then we have 2, 2, 1, 4. So that's my augmented matrix. Okay, first thing you see is that I've got a 1 here in the upper left hand corner, so that's good. Now what I'm going to do is I'm going to draw my matrix down here. I'm going to leave row 1 the same because I've already got what I need, a 1 there. So what I'm going to do is I'm going to take row 2 and I'm going to subtract 3 times row 1. For row 3, I'm going to subtract 2 times R1. And let's just write those up here above so I can do so I need 3R1 and I need 2R1. So I can take row 1 here, multiply everything by 3, and do the same thing. Take this row, multiply by 2. So I'll have 2, 0, negative 6, negative 4. And remember, this is row 1, this is row 2, this is row 3. So what I want to do is take this row, I'm going to put little dots here, this row, and I'm going to subtract this row. 3 minus 3, 0. 1 minus 0 is 1. Negative 2 minus negative 9 is positive 7. And 5 minus a negative 6 is a positive 11. 5 minus a negative 6, so it's 5 plus 6, which is going to be 11. Okay, next what we do is we're going to take, let me use the green here, so we're going to take this and subtract that. Put my answers in green. So 2 minus 2 is 0. 2 minus 0 is 2. 1 minus a negative 6 is 7. And 4 minus a negative 4, that's 4 plus 4, which is 8. Okay, so that's the first thing we got to do. Now, I've got 1, 0, 1, 0. So what I want to do is I want to make this 0, because I want 1, 1, 1, 0, 0, 0. Okay, so let me make a matrix here. We're going to copy row 1 and row 2. Right now. So we got 0. Okay, well, yeah, we will have 0, but we don't know that yet. So let's do this. So and then now this is R1, this is R2, this is R3. So to get this to go to 0, we're going to multiply this number by 2 and subtract it. So what we're going to do is we're going to take row 3, the new row 3, and we're going to subtract 2 times row 2. Okay, so let's write 2 times row 2 up here. 2 times row 2. So we take row 2, multiply by 2. So we got 0, 2, 14, 22. Each one of these numbers doubled. And we're going to take this row 3. Let me put a little dot here. Let's use red. So we're going to take old row 3, and we're going to subtract 2 times row 2. So 0 minus 0 is 0. 2 minus 2 is 0. That's what we're trying to get. 7 minus 14 is negative 7. And 8 minus 22 is negative 14. So 8 minus 22. Okay, so now we want to get a 1 here, and to do that we just have to take row 3 and divide by negative 7. Everything else, the first 2 rows, stay the same. So 0 divided by negative 7, 0, 0 divided by negative 7. Negative 7 divided by negative 7 is 1. Negative 14 divided by 7, negative 7 is 2. Okay, so what the equivalent equations here, x minus 3z equals negative 2, y plus 7z equals 11, and z equals 2. So that's the equations relating to this augmented matrix. So you can see I've got z. If I plug 2 back in here, I'll have 7 times 2 instead of 7 times z. So I get 7 times 2 is equal to 11. Y is equal to 11 minus 14, which is negative 3. And then I can plug that, well, I don't even need it in here because I don't have y, so x minus 3 times z, which I just calculated up here, is equal to negative 2. So you get x here, I've got negative 6, so add 6 to both sides. That goes to 0, this becomes 4. So that's my solution. Z equals 2, y equals negative 3, x equals 4. And if I go back to my original equation all the way back up here, if I take 4 plus negative 4 plus 3 times negative 3 times 2, that's 4 minus 6, which is negative 2. And if you plug in here, you get 2 times 4 is 8, plus 2 times negative 2 is negative 2 times negative 3 is negative 6, so you get 8 minus 6, which is 2, plus z. 2 plus 2 is 4, which equals 4. Okay, so it did work out. Now, to do the back substitution thing, what we want to get is a 0 here and a 1 there. So you go in the opposite direction, and we leave the last row the same because that's exactly where we want it. Z equals 2. So what we're going to do is we're going to take old row 2, this is row 2 now, row 1, row 3. So we're going to take old row 2 and we're going to subtract 7 times R3. Okay, let's write that down. 7 times R3. So this is R3, my updated R3, so you get 7 times 0, 7 times 0, 7 times 1, 7 times 2. And what we're looking at is we're going to take row 2 and we're going to subtract 7 times row 3. 0 minus 0 is 0. 1 minus 0 is 1. 7 minus 7 is 0. 11 minus 14 is negative 3. And then the first row stays the same. Okay, now what the heck do we do? Well, actually we could have done 2 things here, so let me erase that. Just like we did 2 things early on, you can take your old row 1 and add 3 times row 3 plus 3 times row 3. So let's put that in there. 3 times row 3. So we take row 3, multiply it by 3 instead of 7. So you'll get 0, 0, 3, 6. Okay, let's put little green dots here for that. So what we're going to do is we're going to take old row 1 and we're going to add 3 times row. So we're going to add these 2 together to get that. 1 plus 0 is 1. 0 plus 0 is 0. Negative 3 plus 3 is 0. And negative 2 plus 6 is going to be 4. And from that you can see x equals 4, y equals negative 3, z equals 2. These are the solutions. When you have 1, 0, 0, 0, 1, 0, 0, 0, 1, this column is the solution. Okay, so that's that first one. moment. I gotta go back here. Okay. Now we've got this equation. So it's basically all the same procedure. So just gotta wade through it here. Okay. First thing, we need to get 1 up here. So the first thing we do is we just switch column 1 or row 1 with row 4. There's no point trying to make it any more difficult than it is. So we switched row 1 and row 3. Okay. This goes up there, that goes down there. Okay, the next thing we're going to do is we're going to leave row 1 the same because we've got a 1 in the upper left hand corner. That's what we want. So we're going to take old row 2. This is row 2. This is row 1. This is row 3. We're going to take old row 3 and we're just going to add row 1. You can see if I take this plus that, I get 0. So we're just going to add these two together. You get 0. This plus this is 0. This plus this is 0. This plus this is -2, and this plus this is +4. And then we can take row 3 and we can subtract 3 times row 1 because I have a 3 here. So if I take 3 times row 1, here's row 1, triple each one, so 3, -3, -12. 3 times this is that. 3 times that is 3 is going to be 42. 14 times 3 is 42. So we add these two together now. We're going to add row 3, and we're going to actually subtract these. We're going to take this and subtract that. 3 minus 3 is 0. 2 minus a -3. So -2 plus 3 is going to be 1. This plus 12, so that's because we're subtracting 3r. So this minus a minus, so that's 13. And 15 minus 42 is going to be equal to what is that? 43 minus 15. It's 8, 28. 28. Yeah, that's bothering me a little bit. No, maybe not. Okay, we'll see. I think it's okay. Now, at this point, I want to get a 1 here, but I've already got a 0, but I've got a 1 there. So what I can do is I can switch. You know, this becomes row 3 becomes row 2, and row 2 becomes row 3. So that becomes 1, 0, 1, -2. Oh, pardon me. Got me the wrong stuff down here. That's why you got to really be careful. 0, 1, 13, -28. And then this row is 0, 0, -2, 4. Okay, I'm almost there. The only thing is I need a 1 here. So you can see the last thing that I do is I'm going to take row 3 and divide by -2. The other one's just going to stay the same. So if I take this and divide by -2, I get 1. Divide that by -2, I get -2. Okay, so what that's saying is the equivalent equations are x minus y minus 4z equals 14. So that's this one. Then you got y plus 13z equals -28. And the final one says z is equal to -2. So back substituting, I'll get y plus 13 times negative 2 is equal to negative 28. So that's negative 26. So negative 26, I add 26 to both sides, I'll get y equals negative 2. Negative 28 plus 26 is negative 2. And then I back substitute in the first equation. So I have x minus a negative 2 minus y, which is negative 2, minus 4 times z, which is negative 2. And that equals 14. So I've got x plus 2 plus 8 plus 10 is equal to 14. Subtract 10 from both sides, I get x equals 4. So that's my solution. And again, I can go back to my original equations and double check to make sure they work before I go any further. So let's just try it here. Let me just try this last one, the first one. If one of them works, then probably all going to work. So you'd have 3x minus 2y plus z, that should equal 15. Okay, so 3 times 4 is 12. Then we have I'm a little worried here because that's not going to work out. So you'd have that plus 4, and then you'd have minus 2. That's 14, not 15. So where did it go? Oh, no. Is that right? 3. Did I copy something wrong down here? Ah, rats. Okay, let's see if I can figure out what's going on here. Okay, I'm going to pause it for a second here. Okay, so I figured it out here. It's the error's right here. 42 minus, or 15 minus 42 is negative 27. So that comes down to here. So this becomes negative 27. This becomes negative 27. Negative 27. And then we come over here. So this is 27. This is 27. So this one is, you got negative 27, here's negative 26, so negative 27 plus 26 is negative 1. And then we stick in negative 1 here. And so this becomes, here we have 8 plus 1 is 9, plus 9. So we subtract 9 from both sides and we get 5. So that's the solution. And now that you have that, you can plug this into the original equation. So this is 5 instead of 4. So we have 5, 3 times 5. This is negative 1 instead of negative 2. And so what we'll get is 3 times 5 is 15. Negative 2 times negative 1 is positive 2. And so 15 plus 2 minus 2 is 15, which is what it was supposed to be. So 15 equals 15, check. So that's the solution. X equals 5, y equals negative 1, z equals negative 2. Okay, now that's using back substitution. Now the other way is we're going to have to do 2 more operations here. We're going to make that 0, and we're going to make that 0. So we're going to leave R3 the same because we've already solved for z there. And what we're going to take R2, the old R2 in the previous step, and this is R3, and this, oh, I got it the wrong way. This is R1 and this is R3, R1, R3. So we're going to take R2 and we're going to subtract 13 times R3. So we need 13 R3. We'd want to do that so that goes to 0. So 13 times R3. So 0 times 13 is 0. 0 times 13 is 0. 1 times 13 is 13. Negative 2 times 13 is negative 26. Okay. So we're going to take R2 and we're going to subtract 13 R3. So we get 0 minus, let's use blue here. So 0 minus 0 is 0. 1 minus 0 is 1. 13 minus 13 is 0. Negative 27 minus negative 26 is the same as negative 27 plus 26, which is going to be negative 1. And then the next thing we do is we're going to take row 1. Here we have negative 4, so we're going to add 4 times R1 to get this to go to 0. So 4 R1, I mean R3, sorry, R3. So R1 plus 4 times R3. So we need 4 times R3. Here's row 3. So we're going to have 0, 0, 4. 4 times negative 2 is negative 8. Okay, so we're going to take R1. We're going to add 4 times R4. 4 times R3. So 1 plus, add the reds together, 1 plus 0 is 1. Negative 1 plus 0 is negative 1. Negative 4 plus 4 is 0. 14 plus negative 8 is negative 22. 14 plus, see, we're in R1 plus R4, R3. So that's going to be 6. Okay, next, in the last step, we are going to keep R2 and R3 the same. And we're going to take R1. So this is R1 now. This is R2. This is R3. So to make this go to 0, we're going to add these two together. So we'll take R1 plus R2. So we're going to, let's use green here. Just going to add these two together and replace row 1 with that. So 1 plus 0 is 1. Negative 1 plus 1 is 0. 0 plus 0 is 0. 6 plus negative 1 is 5. X equals 5. Y equals negative 1. Z equals negative 2. That's the solution. Okay, I'm getting tired. Okay, same deal here. We're going to create our matrix 2, 0, 3, 3, 4, negative 3, 7, 5, 8, negative 9, 15, 9. This one's making me tired even before I think about it, because we're going to end up with fractions, unfortunately, but that just happens sometimes. The reason I say that is, you can see I have no 1s in the first row, so I can't shift it to be 1s in the first row. And none of these have some common nice common factor. You know, I can't divide this by any common factor. I can't divide by 4. So really the first thing in this case, I'm just going to take row 1 and divide by 2. So I'll get 1, 0, 3 halves, 3 halves. and then row 2 and row 3 are unchanged. It's always the first thing you got to do is you got to get a 1 here in the upper right hand thing. Okay. Now what we're going to do is we're going to make these two go to 0. So we're going to leave row 1 the same. And what we're going to do is we're going to take row 2. So this is row 2. This is my new row 1. This is my new row 3. We're going to take row 2, and we're going to subtract 4 times row 1. And here we'll take row 3 and subtract 8 times row 1. 4, 8. Okay, so I'm going to move this down because I need space. Give me some space. Okay. So let's do this. 4 row 1. 4 times 1 is 4. 4 times 0 is 0. 4 times 3 halves. So that's 12. 4 times 3 is 12. 12 halves is 6. So this becomes 6. And this becomes 6. So that's encouraging. And then we also need 8 times row 1. Well, if 4 times row 1 is this, then 8 times row is double that. So it's going to be 8, 0, 12, 12. Okay, so this row, we're going to take row 2, and we're going to subtract this row. 4 minus 4 is 0. Negative 3 minus 0 is negative 3. 7 minus 6 is 1. 5 minus 6 is negative 1. Okay, so that's the new row 2. And let's do blue here. So then we take row 3 and subtract 8 times row 1. 8 minus 8 is 0. Negative 9 minus 0 is negative 9. 15 minus 12 is 3. 9 minus 12 is negative 3. Okay, now what do we do? Well, I noticed that all of these you can divide by, well, yeah, but it's not going to, I think you're just going to have to do either one. This doesn't matter. I just saw something. Now you guys probably wouldn't notice this, but at this point, notice that this is just 3 times that. And as a consequence, if you ever end up with one row just being a multiple of the other, you basically say, no solution. Okay? Because these are basically the same equation. And just by a multiple. So if I multiplied this by 3, negative 3, and added them together, you get 0, 0, 0, which means you don't have enough information. So it didn't turn out to be as bad as I thought, just because there is no solution to this one. So, you know, in earlier there was this comment which we kind of ignored at the time, which said, if possible, okay, use matrices to solve the system equations if possible. Well, in this case, it's not possible because you end up with that happening. So, now, if one of the numbers had been different, it wouldn't end up this way, and we could solve it. We'd be spending another 20 minutes probably solving the problem. So, lucky for us, there was no solution. And you know, I'll briefly talk about it in class, but there is a way of doing this using matrices on the calculator. And what I'm going to do here is I'm going to pause it for a second and just verify, because what it'll tell me is no solution, and I'll know that I didn't make a mistake. So just hang on here for a millisecond while I solve this thing. Yeah, so that's what I get. So we're done on that. Obviously, I can't give you one of these to solve in a test. I can give you a 2x2 one that you have two equations and two unknowns, or I could ask you to do some row operations on these bigger ones, but it would just take too long, and there's always the chance of making one small error, and then you're messed up. So okay, thank you very much.